Hi, this is Bharath B. I'm a postdoc working with Dr. Moong Chang in the Edge Lab at Princeton University. So, the topic that I'm leading is what we call the interactive cloud. So, we are considering a new set of applications in which the interaction of the user with the cloud is at a much higher frequency than what is seen in the normal applications. So, this is more of a high level proposal talk rather than a paper. We are trying to address the challenges involved in such applications and how can the cloud actually deal with these challenges. So before defining what's the interactive cloud, what do we mean by a non-interactive service? Why do we call the current services non-interactive? Because even now the user is interacting with the cloud in some way, right? So it is more to do with the nature of the interaction and the frequency of interaction. Take an example of Hadoop. This is a very famous batch processing tool where if you want to process huge amounts of data, for example, you want to search for a word among large Twitter feeds, you write MapReduce jobs and submit it to the Hadoop engine, which will do it in a very fast, parallel, and distributed manner and give it back to you. So the nature of the user interaction with the cloud in such a scenario is the user makes a job request, a MapReduce job, and once the cloud finishes executing the job, it replies back to the user with the results. This is very similar to a fire and forget model where the user fires a request and forgets about it till the cloud responds. So the interaction is just during the start of the job and while receiving the response. During the execution of the job, there's not much of an interaction with the cloud. Or as another canonical example, consider Dropbox like file storage service. Here again, whenever a user wants to read or write to his file, he'll send a request or response to the cloud. And the cloud is forced to give certain guarantees as to how fast it will respond to these requests. For example, it might say 99.9 percentile of all requests have to be granted within 200 milliseconds. And that's about it. Or another example of a non-interactive service is a Netflix-like system which hosts movies. The user makes a request for the movie, the cloud responds by playing the movie, and that's about it. So the cloud knows the size of the movie, it knows at what rate it needs to play it back so that the user can see it. Again, all these applications are in many ways characterized by low frequency interaction. So these are what we call non-interactive services. Now let's come to what are interactive services. So I have an analogy for each of those examples in the previous slide. Now rather than looking at Hadoop like batch processing, look at something like Spark, which is used for interactive query processing. In such a paradigm, the user interacts with the processing tool during the execution of each job. In this case, now the cloud has very different challenges to deal with, right? It's no longer a bunch of jobs that needs to be completed and returned back to the user. It has to constantly interact with the user in order to get parameters for the job to complete. Or rather than a Dropbox like file storage service, think of Google Docs like file collaboration service where multiple users are modifying the same file. Now again, the challenges here are very different. It's not sufficient if the cloud just says each user will get a response time of say 100 milliseconds or 200 milliseconds. It needs to ensure that the entire session involving all the users have a good experience. To take the analogy further, rather than Netflix, look at Skype like video conferencing, where users impromptu want to start video conferencing sessions. Here, unlike Netflix videos, we do not know at what the length of the video is, at what rate it's going to be generated, how long it's going to last. So the challenges are far more for the cloud in such applications. So these are the set of applications that we are considering, applications in which multiple users are interacting with the cloud at high frequency sessions, and the cloud has to still maintain sufficiently good quality of service guarantees. So in order to achieve this, what are the main research goals? Clearly, the first step is to define some metrics for interactivity. Now, the metrics for latency driven services are well known. For example, as I've already mentioned, Amazon Dynamo, one of the most famous key value stores in the world today, makes the guarantee that 99.9 percentile of all read-write requests will be satisfied within, say, 200 milliseconds. Similar to that, what kind of interactivity metric that will we want for interactive services? Again, any interactivity metric is going to be a function of the difference between the output and the input time series. It could be various functions. For example, it could be the minimum amongst the difference between the output and input for all the applications corresponding to a certain interactive service, or it could be the variance, which kind of measures jitter, or it could just be the maximum experience by a certain application. The first step is to understand what our target is that we want to achieve. That's the metric. Now, once we have achieved the metric, the next step is to understand the trade off, or in other words, what is the amount of resources that we need to achieve a certain metric. This is important because only if we understand this trade off can we improve the trade off for interactivity. And the final step in this is to exploit various degrees of freedom. Now, even for non interactive services, the cloud is hard pressed to answer all the user demands and maintain quality of service guarantees. Now we are imposing even more on the cloud. The only way the cloud is ever going to be able to achieve sufficient QoS guarantees is to exploit certain degrees of freedom. What do we mean by that? I'll just go through some of the examples here. Now, let's say coding theory. Now, coding theory is often used to reduce the amount of space required in a solution. Now, exploiting this, maybe the cloud can ensure very space efficient solutions that will, in effect, reduce the number of resources required in terms of space and memory. It will make the system more fault tolerant because you can keep more replicas for a certain number of faults. Again, another thing that we can exploit is cloud dynamicity. Now we know that the cloud has, in fact, the main defining point of the cloud is that it can dynamically allocate resources. Can we use this to make sure that interactivity services are better serviced? So that's the final step, to exploit degrees of freedom to ensure that standard metrics of the cloud, like resource allocation efficiency, fault tolerance, or fairness, is each user being treated according to his needs, according to his what he's maybe capable of spending, and provide a complete solution for interactive services. That's the goal of this project. And this is just a summary of the research goals that I've already gone through. That's about it. For more information, please contact me at Bharath B at Princeton.edu, or you can look at our website at scenic.princeton.edu. Thank you.